The cosmos has now delivered data so unsettling that a Nobel Prize-winning physicist has broken his silence with one simple, terrifying message: this is not our universe. What exactly did the James Webb Space Telescope find at the very edge of everything? And why are scientists warning that it could rewrite the very foundation of cosmology as we know it? Keep reading, because what you're about to hear changes everything. In a quiet corner of the sky, saturated with ancient light, the James Webb Telescope captured what initially appeared to be a simple yellow splotch. At first glance, it was unremarkable, just another distant object in an endless sea of galaxies. But when astronomers zoomed in and took a closer look, their assumptions and expectations collapsed. That tiny glowing blob was not just another galaxy. It turned out to be the most distant galaxy ever observed, one that had formed merely 290 million years after the supposed birth of the universe itself. Herein lies the impossible. This galaxy, now designated as a record-breaking object in the annals of observational astronomy, was simply too massive, too luminous, and too evolved to have formed so soon after the Big Bang. According to our current theories, the universe at that stage lacked both the time and the material needed to create a structure of such magnitude. And yet, there it was. And that galaxy was not alone. James Webb has now found dozens more like it, each one presenting itself as a paradox, as if daring the very foundations of astrophysics to explain their existence. Each discovery defies the standard models of cosmology, breaking every rule we thought we understood about the early universe. These are not just statistical anomalies. These are cosmic paradoxes stacked upon one another. As scientists began digging deeper into the data, what they discovered was even stranger. Some of these early universe objects were not just massive, they were utterly alien to any kind of structure previously known. Unlike typical galaxies, which convert about 10% of their gas into stars over billions of years, Webb uncovered at least 3 galaxies that had already converted 100% of their available matter into starlight. No remaining gas. No cosmic dust. Just pure, blazing stellar energy. That's not just unusual, it's impossible by the rules of every existing model of galaxy formation. And so, scientists are now asking a far more terrifying question. What if these aren't galaxies at all? What if we're not even looking at the early universe, but instead seeing something entirely different? Could these be structures from another dimension, remnants of a previous cosmos, or perhaps even intrusions from another universe altogether? To understand why this is shaking the field of cosmology to its core, we have to delve into the concept of the Hubble sphere and the observable universe. The farther away an object is from us, the faster it moves away, due to the ongoing expansion of space. At a certain critical distance, known as the Hubble sphere, galaxies are receding from us faster than the speed of light. Common sense tells us we shouldn't be able to see anything beyond that point, and yet we can. Why? Because space itself is stretching, and the boundary of what we can observe keeps expanding along with it. But beyond that ever-expanding boundary lies something far more terrifying, a region of the cosmos we will never reach, and one that will never reach us. And yet somehow, the James Webb Space Telescope is now picking up light and signals from these forbidden, impossible zones, regions where no light should ever have reached us. This leads to one inescapable and disquieting conclusion: we may be seeing beyond the edge of our universe. And the truth is, no one knows what lies on the other side. Webb's unprecedented stream of data is now forcing scientists to ask what was once unthinkable: what if the universe never had a beginning at all? Some Nobel laureates are now openly questioning the validity of the Big Bang model itself. Because if galaxies are forming faster than the laws of physics allow, if light is reaching us from beyond cosmic boundaries, and if structures appear that defy all known constraints of time, scale, and mass, then perhaps our understanding has been fundamentally flawed. Maybe the early universe isn't early in the way we define it. Maybe what we're seeing is not a timeline of creation but a fracture in the fabric of reality, a place where 2 or more universes overlap, or worse, where something unimaginably ancient is bleeding through from a realm older than time itself. Whatever it is, it doesn't fit into our equations, and it never will. Among James Webb's most overlooked discoveries is something not seen, but heard, or rather, detected. While measuring the background noise of the universe, Webb's sensitive instruments picked up a faint but rhythmic oscillation. This frequency does not match any known cosmic phenomenon. It's not a pulsar. It's not gravitational waves. It's not residual noise from the cosmic microwave background. And yet it repeats. At precise, mathematically perfect intervals. As if it were generated, crafted, by something intelligent or structured. Some astrophysicists have already given it a nickname: the heartbeat beyond time. Others are more cautious, theorizing that it could be a signature of exotic matter, something that exists only outside the known boundaries of our universe. Here's the chilling part: the frequency isn't random. It follows a mathematical pattern. It appears to have been encoded. Not naturally occurring, but planted, waiting to be discovered. And this is just the beginning. One of the telescope's most unexpected findings is a huge imbalance between what we see and what we feel. Galaxies at the farthest reaches of space appear to have enough gravitational pull to bend light, warp space, and influence nearby structures. Yet, visibly, there's nothing there. No stars. No planets. No nebulae. This isn't just dark matter. It's something else entirely. Researchers now believe that Webb is detecting massive gravitational anomalies that don't correspond with any known source. These are like phantom fingerprints pressing down on space-time from a realm we cannot access. But where are they coming from? Some theorists are now suggesting the unthinkable. Perhaps what we're seeing is the shadow of another universe, one colliding with our own. What if everything we know has a mirror image that we cannot perceive? Not metaphorically, but physically. A fringe theory once dismissed by mainstream cosmologists is beginning to gain traction once again. The idea that a mirrored universe exists where time flows in the opposite direction and the laws of physics run backward relative to ours. And what has changed? The James Webb Space Telescope has provided observational evidence that demands such re-evaluation. In particular, Webb has recorded behaviors of particles and rotational dynamics in galaxies that suggest cosmic asymmetry, subtle clues that indicate two different physical systems may be overlapping. It's as though our universe is being pulled in one direction, while another universe, just beyond our reach, is pulling in reverse. If this theory proves correct, it would mean we are not alone in the multiverse. It would mean we are, in fact, entangled with a shadow reality that mirrors our own existence in eerie and unimaginable ways. In a final and astonishing twist, one of Webb's long-range spectroscopic instruments was tracking a specific light signature near the edge of the observable universe. This light, like many others, was expected to fade, absorbed by the void or stretched into invisibility by cosmic expansion. And yet, something extraordinary occurred. The light reappeared. Not from the same region. Not from the same time. But it came back with the exact same spectral fingerprint. It was as if the light had been reflected. Bounced back by something. This wasn't just residual radiation. It was a cosmic echo. And now scientists are left to wonder. An echo of what? There are only two possible explanations. Either the light looped around the curvature of the universe, implying that space itself is finite and closed like the surface of a sphere, or, far more disturbingly, it struck something at the edge. Something reflective. Something massive. Something that should not be there. The James Webb Space Telescope was built to peer deep into the past, to reveal how the universe began. But it may have done something far more profound and terrifying. It may have revealed that our universe is not alone. The impossible galaxies. The phantom gravitational masses. The mirrored particle behavior. The encoded pulse. The light echo. Each of these revelations is like a hammer blow to the illusion of certainty, chipping away at our comforting belief that we know where we are, when we are, and what we are. The Nobel Prize-winning physicist who broke his silence was right to say it. This is not our universe. And perhaps, this is the terrifying truth we were never meant to confront. Maybe we are drifting on the edge of something ancient, something vast, indifferent, and far beyond human comprehension. A deeper structure. A larger reality. A universe behind the universe. And now, the real question isn't whether we are alone in the cosmos. It's whether we're even in the right one. Let us know in the comments. Do you believe the James Webb Space Telescope has already peered into another universe? Or is it simply our fragile understanding of reality that is beginning to crack? Subscribe and turn on notifications, because the cosmos just blinked back. If the James Webb Space Telescope has indeed glimpsed beyond the veil of our known reality, then we are no longer just observers of the cosmos, we are explorers of something far more profound, a multiversal rift, a fracture in the continuum we once thought was whole. For centuries, humanity has charted the stars with a sense of order. From Newton to Einstein, from Hubble to Hawking, we believed that the universe could be explained by equations, measurements, and predictable laws. But what happens when those laws no longer apply? The discoveries emerging from Webb are not just anomalies, they are provocations. Each finding invites a fundamental question